Hello everyone and good evening. I wonder if you can hear me. Yes, you should be able to hear me. Do I hear myself? Let me double check that. And I guess we're ready to go. Okay, I can hear myself. Perfect. So, apologies for the delay. I was basically finishing the mission for today. If you're new to my stream, I'm basically posting these tasks at the end of my stream, which are like somewhat programming, somewhat security, as in somewhat crypto, somewhat something else. Well, I haven't been doing it for long, so there have been so far 3 missions, and 2 of them were programming, and 1 of them was crypto, therefore, well, yeah, but I'll try to like mix it up a little from time to time, and there, from really easy stuff to more advanced stuff, and I was just finishing today's mission, so, yeah, it took me a little longer than I expected. Anyway, so today's moderator is KrzaQ. Thank you very much, KrzaQ, for being here. I actually think I need to span my browser because I totally forgot to do it before the stream. Anyway, so today's topic is going to be the Confidence Dragon Sector CTF 2017, the offline finals, which it was a CTF organized by my team under the lead of Valis, who is the acting captain of Dragon Sector. And it happened on the Confidence conference in Krakow, where it was an offline CTF, but anyone could participate. It wasn't like an offline final. Like if you are on the conference and you were like a 4-person team or less than that, you were able to participate. And there were quite a lot of fun tasks. The winners got 10,000 Polish zlotys, which is around $2,500. So it was not too bad, in my opinion. I think like around 21 teams participated. There were some really good teams from actually all around the world. Like there was a team from Taiwan, there was a team from Israeli, and some European teams, and so on. So actually the teams there were really good teams on the CTF, basically. There were some fun tasks as well. A couple of, 2 of them created by me, other created by other people. Some tasks were pretty physical, as in hardware. For example, one task was where you had a drone, basically. A drone was locked in a cage built before the CTF. And you had to hack the drone, basically. It was first a reverse engineering challenge, as in you had to get a Wi-Fi password from the firmware, then you had to basically exploit it and get control of the drone. So yeah, that was pretty fun. Then there was another challenge, like a reverse engineering challenge for Nintendo, where you had a light gun and you had to point. There was 0 and 1 on the screen, and you had to basically shoot the correct combination of 0s and 1 to get the flag. I am going to actually show a reverse engineering of that task today. Yeah, there was actually also some exploitation, some more default reverse engineering. So I decided to basically do today's episode on that. I will show probably 2 or 3 solutions to reverse engineering tasks, because actually what we usually do is, before the CTF, every task which gets published on the CTF, which is used on the CTF, has to be tested. And I tested a couple of them, and I made 2 of them, so these are the tasks I'll focus on today, because I basically know how to solve them, and I know exactly how much time it will take me. Exactly-ish. Anyway, so let's do the standard stuff, which I always do at the beginning of my stream. Let's start with shoutouts. So again, thank you to KrzaQ. His website is... Oh, I actually do not have my zooming in application turned on well. I need to fix that. It's not actually my application per se, it's actually an application I am using made by sysinternals guys. Yeah, so visit KrzaQ's website. Sometimes he posts about C++. If you actually understand Polish, there's another site he publishes more frequently on, but I guess you should ask him to publish in English as well. Yeah, it's actually quite fun if you change this to DSP, it gets to the Polish version of the blog. Another shoutout is to Live Overflow, as usual. This guy basically posts awesome stuff about security, about CTFs. So if you're into security, CTFs, and so on, and if you're, well, learning or want to learn new things, basically check out his channel. It's like Live Overflow on YouTube. Then another CTF channel, or CTF related channel, which is Murmus CTF, or Mus CTF. This one. This is basically a person who's doing live streams, like similar to what I'm doing, but he's spending them on actually solving the challenges, and usually puts more time into the streams than I do. And does also weekly streaming, or like bi-weekly or so on. So totally check out his channel. It's Murmus CTF with an S here, Murmus. So yeah, pretty fun stuff. Okay then, so let's maybe chat about the last week's mission. So how to solve it and what was it about. Let's see if there are any solutions. Actually, if we go, this is not the channel I want to go. I want to go to my English channel. Now, if you have any questions, just chat with this guy, let him know, and he will pass it to me in a magical telepathic way. Or something like that. Or he might be using a website we created for that, for admins. Well, one of the two. Anyway, so basically, let's see. The last mission was, I am actually going to show it on the screen, but I need to find it first. Missions, this is today's mission, this one, perfect. So, one of our agents, Agent Huffman as we like to call him now, sent us another message. He said that he took the plain text message, interpreted the bytes that made the message as a large little endian encoded number, then encoded that number in base 4 system. I'm not going to even pretend I can pronounce this word. Quaternary, probably it's quaternary though. Anyway, and then compressed it with Huffman encoding. The message goes as following, and here's a series of zeros and ones. By the way, if you're doing these challenges, keep in mind that there is usually a link inside the challenge that leads to this part or the whole message in text encoding. So you don't have to type these zeros and ones, just go to this link and you will have a plain text version of it that you can just copy paste. Okay, of course we asked him about the Huffman tree, because you know, to decode the Huffman you need a tree. Like previous mission was about that, basically. But he forgot to save it, so there is no Huffman tree, we still have to decode it. And the question is how to go about it. Let's see first if anyone solved it actually. I don't have the slides for it today, I usually am doing slides. So, yeah, this is the correct answer. This is from the top comments. Let's start with newest first, and I'll go from the bottom actually. This is still the best answer, and this is the correct flag. It was a Huffman forest, I guess. Because, so the flag is like this because what you had to do is you had to guess the Huffman tree. And you not only had to guess how the Huffman tree did look like, right? For example, in the previous week, if we go to the previous mission, this was the Huffman tree last time, right? So it's, you know, there's a root and it goes like, you encode a 0, for example, if you go one direction, and then you encode 1 if you go the other direction until you reach a character. Now, in case of the Huffman forest, as I jokingly called it, you didn't know how this tree looked like. But of course, if a tree is like this size, this many leaves, then the number of possibilities is quite high. However, if you remember the mission text, is that it was the message was actually encoded in the base 4 system. That means that there are only like 4 digits, right? It's 0, 1, 2, and 3. So there are only 4 leaves of a tree. So the tree is much smaller. It's like only basically this part of the tree. It would be something like that. And there are only so many ways, I think like 5 or 6 ways you can form a tree with 4 leaves. A binary tree with 4 leaves. So you had to obviously go through all these possibilities, and you also didn't know like which character is where. You know you had digits like 0, 1, 2, and 3, but you don't know if like this on this leaf it would be 1, maybe it would be a 0, maybe it would be a 3. You don't know that. You just know that it's unique, but the number of possibilities here, both on how the tree should look like, and the number of possibilities on like what character is at a given position, it's pretty limited. And you can just go through all of them, brute force it basically, and get the message, and that's how you solve this task. Now, this is the person, I guess, who got the first solution. Congratulations to you, Hopekl, I guess. I'm sorry if I totally butchered your name. And this is the code which goes with it. Yeah, as you can see, like permutations, then different variations of the trees. It seems that I actually like it. It's the binary tree encoded as a series of recursive tuples, and it seems there are only four possible ways to encode this tree. I think there are 5, but I might be mistaken. Don't listen to me. If this worked, it worked, right? Maybe he missed one. Maybe I am overthinking it. And then it's just a standard Huffman decoding. If you're new to IT, Huffman is a decompression algorithm, or a compression algorithm, so just go to Wiki and Wikipedia and you will see how it's usually decoded or encoded. So yeah, this is basically the code which brute forces through all the trees, and it was enough to decode this message, so again, congratulations. Then Marek was submitted another code. If you again go to the comments, you can see these codes. Similar, yeah. I like how this like an iterator was used with yield, but that's pretty nice, a nice solution. Apart from that, I guess it's pretty standard. So one more tricky part here might be how do you convert the series of 0s and 1 into a large integer, which is base for, well, not really 0s and 1s, but 0, 1, 2, 3s into a large integer, and the answer is you just multiply it basically, but you don't have to even do that, because in Python, if you pass to int the second argument 4, this is actually the base system, so you get it free in Python. So if you actually try to solve it in C or C++, it would take you way more code, just because you'd have to probably, well, make your own implementation of it. Okay, I guess I'm going to give you the 2 links after all. KrzaQ, could you paste them to IRC as well? Thank you. Okay. Yeah, KD, you also solved it. Let's take a quick look. Anyway, if you thank you basically for sharing your code. I think it's really important, especially for people who didn't solve it and are curious how to solve it, or just curious how other people's coded different fragments of the code, which, you know, you can always learn the really cool tricks, like the yield thing, for example. Okay, again, like, I guess this representation of a tree is the easiest way to go. I don't know if I would actually code it this way. I'd probably overthink it, so I really like that you, that all the solutions I'm looking at did this. And it's also Python again, so which is nice. Okay, I'll give. Yeah, so that's it. Then Josh also, his code, you can find it here. I'll give you a link as well. Let's do a quick look. I think Josh actually, yeah, actually went a different way, which is, yeah, oh no, yeah, he basically went a different way. Instead of representing the tree, he decoded the bits itself as different variations. Like he, in other solutions, there was actually a code doing getting a tree into this 0 and 1 form, and he actually did it manually, and which is also a nice solution. It saved some code, so this is why this code is actually shorter. So really nice solution as well. And Arthur also solved it, and there is also I guess this might not be actually the correct answer. I am sorry. Arthur also solved it, and I don't know. I'm sorry, I have no idea how to read your nickname. I will not attempt to do that. Oh, this I guess this is a sign of doing the brute forcing manually. That's also fine. Whatever works, right? Works. And this one. Yeah, also manual brute forcing, just checking all the trees without actually writing a loop to do it for you. That's fine as well, especially if there is like a small number of combinations. So again, thank you very much for sharing your code. I'm pretty sure it's like a lot of people find it useful, especially that it wasn't the easiest task of tasks, so that's why it had level 6 actually and difficulty. So congratulations. Yeah, if yeah, at some point, like when we have actually a website for these live streams, we'll do a list of these all the code, all the blog posts written about the missions and the solutions and so on. I guess on the Polish live streams, the writing blog posts is a little more popular. There's at least 2 people who, including KrzaQ, who are writing blog posts about the solutions, which is also really cool because they include, you know, text description, what exactly is going on, what they are doing. It's really useful for beginners as well. Sweet. So let's go to the CTF challenge. First, my challenge, one of my challenges is actually available already. Well, 2 of my challenges are already available on my blog. You might remember Starblind. Starblind was a task which I created for the, well, not qualification, the teaser CTF, which we did a month ago, or like, was it 1.5 months ago? And actually, it was a JavaScript crack me. Well, you can see it's running in the browser, right? But it's not like Knuckle or anything, it's JavaScript. So I did a second and a third part of it. The second part was also, it's called Starbase. So if you just change the link to base, you will get it. Here you go. I'm going to paste it around again. And yeah, and this is the second part of it. So this is the first crack me I'm going to show today. And I guess I'll see if there are any quick questions. There are 2 questions, so I'll go quickly through them. Can anyone add subtitles for the Polish stream, please? Want to see OS Dev streams. So it's like this. Yeah, if anyone wants to donate subtitles to my streams, I'm happy, really happy to accept them. That being said, I don't really personally have time to do it. It takes like, I don't know, 20 hours of work to actually transcribe one episode. So yeah, I would be really happy for donations if somebody would be willing to donate the SRT format of subtitles, because that's what YouTube supports. And they can even be in Polish, because once you submit the subtitles on YouTube, the translation gets so much better. You know, the auto translation from Polish to English, it gets like, it's almost like normal English, almost. So if somebody would like to translate them as well, that's even more awesome. But again, it's a lot of work, I realize that. That being said, well, all my streams I'm doing in English are about, you know, security or like reverse engineering, blah, blah, blah. And the Polish streams I'm doing more about programming. So that's why I have an OS development series there, or like some genetic programming or some other stuff. So if you would like me to do some programming stuff on my streams, on my English streams, I'm more than happy to do it. So just let me know in the comments under this video, please. Okay, and another, Piomar123 says that there were 5 trees, but the last one would need an even number of bits, which was not true. Okay, that's a really good heuristic. I am amazed. I didn't know that. I didn't check for that. Thank you for that comment. Okay, so let's do this task. Did I give you the link? Yes, I did. Perfect. So how do you approach a JavaScript crack me? Well, first of all, you check if it works. It works. Then you can spend, I guess, like 10 minutes reading this or checking if your CTF team name comes up here, but I guess I'm not going to do that for obvious reasons. Instead, I'm going to, well, I can look in the, I cannot display the source code, so it's Ctrl-U to display to view the source code. And it's something, 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 and then a huge data URL. It's the same story that was in the previous iteration of my CrzaQ, which means this is just this isn't really an obfuscation even. This is just here so that the whole CrzaQ fits into one HTML file, because that's the way I like it, for all the assets, all the graphics to actually be there. Cool, so let me download it. I just need to create, I guess, another directory. Perfect. Now, okay, here we go. Here's my total commander, so I'm going to press Ctrl-N, paste the link and download it. Ctrl-N and total commander is actually downloads. Like, you could wget it or just press Ctrl-S to save it here. Now, what do you do first? You obviously... Oh, I'm sorry, I have wrong config loaded for Vim and the font is really small. I am going to fix it. I need to write a script to actually change all my configs before I stream, because currently I do it manually and sometimes I forget it. My apologies. Okay, here we go. Okay, so again, let's move it here. Yeah, here it's in bigger font. I guess what I'm going to do, I'm going just to remove everything from here up to the beginning of a file, then I'll go to the end of a file, and I'm going to basically backtrace until I remove this part. Now I'm going to remove new line, save it, and that's it. I'm going to just decode it in this would actually work, but yeah, whatever, I'm going to do it in Python. So cmd, and it's just standard base64 stuff. So open, what's it called again, whatever, read strip to remove, the white spaces at the end. And I'm going to assign it to something and decode base64. Now I just need to write it to some other file, so open asdf.js, because I know it's JavaScript. It was in the script tag, so it has to be JavaScript. Well, and I guess not true for Internet Explorer, because in Internet Explorer you could also have Visual Basic script there. Yeah. Right, D. Okay, perfect. Now exit. And we should have this file. It's obviously smaller. And there's more base64 here, but it's called asset. Asset usually means bitmap, and it creates an image. So this is probably some PNG stuff. We don't care. I mean, just looking at the CrzaQ, you can see that there is some, like, this is an asset, this is an asset, the font is probably an asset, the background is probably an asset. So there will be a lot of PNG stuff. We don't care about it. I'm just going to quickly scroll through it. Maybe I'll even remove it later on. I'll take a look later. Then the plasma stuff. Plasma stuff is for the sun. So then sun palette. Let's ignore it. I am going to do Unix. I'm going to run. No. I'm annoyed by the !m signs, so I need to run those two Unix SDF.js. Perfect. Okay, it should be fine now. So let's see what's going on in this CrzaQ. First of all, what will be the first code which is executed? Well, obviously all the global variables and so on, so there are some... Oh, show FPS, we probably might, if we change it to true, it might like pop up the FPS, we don't really care. Then there are some canvases, which I guess means just graphic stuff. We don't care about graphic stuff. I don't know, some cryptic message here might be related to the text. It's the scrolling text, which is actually here. Blah, blah, blah. I guess you can look up quicker if your team is actually here. Oh, perfect. Password. Password sounds really interesting. Well, we could, change this to true, but this doesn't give us the flag, and we need to get the flag. So yeah. The question is the stream from my old computer? No, it's from my new computer. I finally put it together, so it's finally a new computer. It has 8 CPU cores, so 16 logical threads. So far 64 gigs of RAM, but I already ordered another 64 gigs. So yeah, it's my new computer, everything works, I'm super happy about it, and it's really fast, so yeah. There it is. Anyway, so let's see where I guess we'll see where the password is, what's happening to the password. So I'm going to just look for the password string. Gpassword, it's here. Okay, length, blah, 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 then, okay. So we know the password is probably 24 characters. 24 characters is usually too much to brute force, to do a full brute force, unless we can do byte by byte. So there's a question, is it a deja vu? Have I seen this solution before? You have seen the solution to Starblind, which is the first level of this JavaScript crack me. Now this is the second level, so it looks similar, it feels similar, it's a different crack me. Yeah. That being said, the graphics engine used here is reused. I'm not going to analyze, I'm going to focus on the CTF challenge itself. So anyway, we know that the password is like 24 characters. Let me look further to check password. Yeah, check password. Also same stuff as in the previous level. Just go here, let's see what's going on here. It calls, well, checks again if it's 24, we already know it's 24, and it calls something like index. And there's a method called login, and it gives it the password, and it gives it a callback to call if the result is known, and then the good password flag, I guess it's set to true or false. Now, so won't the code appear in DevTools at some point anyway? Yeah, we'll get to DevTools soon, basically. So I guess we need to check what's index. Well, if you played Alien Breed, you know what index is. Alien Breed index. Let's just go to images. If you haven't played, it's a really awesome game. It's like, yeah, you have aliens and you shoot them, and if you want to buy weapons, you go to this computer, and it's called an index system. So this is what the reference is about. Now, let's get back here. Let's see what this index is all about. So I'm going to look for index, and it creates a new class called index network interface. Perfect. And I guess this is, oops, apologies for that. I scrolled, I scrolled, I think, enough. This is a class, so it's like a proper JavaScript class, and it has some workers. Now, a worker in JavaScript is basically a thread. So you have these, but it works in a different context. So, you know, when you have when you think about C++ and you think about, or Java, and you think about a thread is something which works in the same context as the rest of your process, which means it has access to all the global variables, all the objects in memory, so you can pass a reference to a thread and it will be able to access the object to which the reference is to. That's not true for JavaScript. A worker is like a separate thread. It runs in the background, but it doesn't really have access to the context of the web page, right, which created the worker. And yeah, you just pass it basically the JavaScript file, or in this case, a data URL. So we'll have to, well, we won't have to decode it, I will show you why. But there seem to be quite a lot of workers here. Like at least a couple of them. And then if, so this is a constructor, right? Then it does something and creates binds a message. So basically the way you communicate with a worker thread in JavaScript is you send it a message, like post message, right? And the way the thread communicates back is it sends you a message. So you have to bind an on message function to actually, so this is a function that will receive the messages. And I guess this is the message receiver. Let's see what's happening here quickly. It gets, I guess it expects the data to be an array of some sort, and it gets a destination and an argument, and if the destination is response, then it calls the login callback. The login callback sounds a lot like the function which says whether the good password is true or false. So we already saw that. Now, if this isn't true, then it goes to this, which is if destination is in this index was this array which we saw with you know, like actually a dictionary which the created workers were assigned to. Then it looks up the destination there and it posts the message to a given thread. So this is basically a message router, as in if one thread, I guess, wants to send a message to another thread, it actually goes here and it checks the destination and it forwards the destination, sorry, the message, not the whole message, only the argument, to the destination thread. So this is a message routing system. Okay, so that's pretty handy because we can actually maybe modify it later and see what's actually going on in the console, right? Now, let's see if there are any quick questions. Okay, there was a question, wouldn't the code appear in the DevTools? I already addressed that, but we'll get to DevTools soon enough. And there's also the login method, which calls 00 as in 00 with, well, calls. It sends a message to that worker thread, and the message has two arguments like login and p. The p is the password, I guess, and it says the login callback to callback, so as we guessed, right? So I guess the big question is here, what does this code do? Now, if I click F12, I get the DevTools, which again, you wanted to see. And if you go to sources, to this tab, you actually see all the worker threads which are spawned. So you don't really have to do anything else. You just like click on this thread and see what code is it running, right? Have I considered compiling a level for this into WebAssembly? Yes, I did consider that. I didn't do one yet. So yeah, if we just go here, it's really nice from home. Pretty print this minified file. Yeah, totally. We can click here, like this icon to pretty print it, so we don't have to read this ugly form, which is quite ugly. Click. Okay. Whoa, constants. Constants are always cool to find. So yeah, good. I have no idea what this is. I don't care. Let's just look around. This is something else. Again, I'm going to prettify it. I'll just go through all of these and do the same. Prettify. Prettify. Yeah. I guess you get the picture. Just prettify everything. And then I'm going to like jump through these tabs and figure out what is what. Cool. No. Oh, more constants. Really good. Okay. What I don't know is I don't know which thread is, you know, the 00 thread which this sends a message to. I guess the login string might appear somewhere there, so let's just look for that. Yeah, can I increase this a little bit? Sorry about that. No login here. Sorry, does it depretify my stuff which I already prettified? This is... Oh no, it's like, it has a formatted version and non-formatted version. So I'm going to close the non-formatted ones. Formatted, non-formatted. Non-formatted, this is formatted, and I guess this is not formatted again. I don't know, I'm pretty sure like half of them already disappeared. Oh no, maybe they're here, never mind. Okay, and this one. Perfect. Now, login. Doesn't look like login. This isn't formatted. Let's close it. Login, now login here. Oh, perfect, login. So what's going on here? It calls an return void as... I have absolutely no idea what this syntax does in JavaScript, sorry. But it calls an add input with t, and t being... Why does it do it like this? Because t... Oh no, okay, I thought this is... Yeah, I'm sorry. I actually thought we are talking about this t here, but it turns out there's a variable named the same way. So it takes the, I guess the password, right, and it calls this add input thing on s. Now s is a new n, and n is a... It's something if you do at input it just posts a message to 60 with 0 and with the with I guess the password. So we know that we will need to probably look up this thread as well. And there's another thing called here, which is system IRQ, which does, if it's equal to 7, it actually posts a message called response. So we saw already the handling this message somewhere else. So it basically looks like a set of threads which are communicating with each other, chatting through the, basically through this message loop. So maybe the task is about like going to some other thread and just see where it's going, like the message, the password which we pasted, where it's going. Let's just look around what's going on here. This looks pretty interesting. You can observe here that this is a byte array, right? A byte array of 8 kilobytes. So it's 8 kilobytes. And there's a function on message, so, you know, handling the incoming messages. It gets some arguments, and if s is equals w, why is it w? Then a, so this array of n is the argument, is equal to e, where e is an argument. So just, if, I guess w is for write, if s is equals w, then it writes to this array under the specified index. Else, so if s is not equal to write, then it posts a message to, that's quite funny. When it posts a message to this one, like 167, and the message is m, and the address, and the AJN. So it actually like looks like it reads the value from the array, from the specified, yeah, so this is probably the read, like, right? And it posts it back to, this is probably what it considers to be the source, like 167, which is some unknown thread. But this starts to look a lot like RAM. Like if you would create a virtual machine, this is what a RAM module would look like. So maybe this is like a virtual machine made by workers. So the workers basically, you know, you have a virtual machine which has, I don't know, a CPU, some devices all around, and they just communicate with messages. And this is the RAM part, right? So the random access memory. Let's look what this is. This has actually some values here. They look pretty decentish. And what's going on here? It again has some free arguments, and it looks in T. What's T? Oh, T again. It reuses the argument name to name a local variable. Awesome. I love name shadowing. Doesn't help analysis at all. Okay, but it looks through the A, and if S, whatever S is between this number and this number, let's say the number at 0th and 1th index, then it posts a message to this. Oh, this is the name of the worker thread, like name the index or the destination address, whatever you want to call it, and it grabs these 3 arguments and basically posts it there. So this looks like a router of some kind, I guess, and yeah, I don't know, maybe a device router or maybe a memory router or something like that. Let's look, what's this? Oh, perfect, there's a constant here. I love constants. Well, it's not ASCII, I'm pretty sure about that. It's probably not Unicode because there are negative values as well, so I don't know what's that. Maybe XOR key at some point. An XOR key, right? And, oh look, there's, what does it do with the array, by the way? Oh, perfect, you can write to it. And it checks if O is the first argument. If O is equal to this, then S is assigned the modulo A length. What's A? Oh, A is this. Okay. So, and what's S? S is a global variable. Okay. So if we send it a write message with this address set, then it for some reason takes a value from this array and stores it in this global variable. Okay, that tells me nothing, but that's fine. Let's see what this is. Another address. So this looks like maybe a RAM address, and maybe this is a memory mapped I/O, if you think about how computers work. And then to T, is T a local variable again? No, it's a global variable again. It assigns D. Oh, and D is, what's D? Sorry. It assigns to T the value D. Okay, that's fine. Sorry, it didn't take the value from this array. It actually like just took an index, I guess, because it does modulo over this. I have no idea why it's writing some value to T, but whatever. And if O is between 0 and 2, then E, which is this, I guess, array, from O is equal to D, where D is the value which is transmitted. So it's, I don't know, some settings, some registers, maybe it's some kind of a device emulator. This is the interesting part. This is crypto. Like you can just see this is a plus operation, then a XOR, and then a minus, right? So this is your standard daily crypto with A, S. So S is again this global variable, A is this constant. So this is either encrypting or decrypting something. My guess is it's either decrypting or encrypting the flag. So it's good to know that it's here actually. Perfect, let's see what else we have got. What is this? Well, what are you? It seems to be a string. And if it has 2 arguments, so the thread, again, it's an on message, so it's handling messages, right? If A is equals, what's A? Oh, the argument is equal to 0, and the second argument is equal to 1, then it assigns to T is again a local variable, an ASCII code or Unicode code of a character, and to S it assigns, no, it actually, this substring, actually what it does is like if S before it is ABC, then after it just pops the first character, so it just becomes BC. Yeah, okay. And then it sends it to, again, this number like 167. My guess, like everything seems to communicate with it. It's either some emulation of, I don't know, like a North Bridge or South Bridge, or maybe it's the main CPU. Yeah, and it sends it P and ET, where T is this thing, and E is actually the argument which is passed here. Well, okay, that's fine. I have absolutely no idea what this E is here, but it passes it basically. Oh, and actually if this isn't true, then S is, you append a string here. So it looks like it's like what's it called? Like a FIFO, right? Like a first in, first out. So it, like on one hand you can, yeah, it's basically a pipe. On one hand you can put some data in, and on another hand you can read the data back. So something might be putting data here, and then it might be like something else might be reading the data from it. Okay. This is the interesting part. What are you? Again, we have an array of bytes. No bytes. It's an array of D words, like a 32-bit words. And then it's called A, and there are a lot of assignments here to this, and like all these funny functions are used. Well, what do we So these functions are really easy. I mean, it's just, you know, it's forming a D word. So what is it about? And there is like a number, and then whatever are the arguments, like this they're shadowing the name. The minifiers in JavaScript are amazing. They are just shadowing the name of a function. That's amazing. Anyway, so as the arguments moved on specific positions, so these functions are just to create a D word. Now the question is, why do you need a lot of functions to do the same thing? I guess this is because this changes, right? Or the amount of arguments. I have no idea what this might be. And then it actually uses all these functions to create some variables and put it inside this huge array. Well, not really huge, but it puts them there. Then actually creates another function and calls it with some arguments and another here. And this is actually the only derivation from it. It calls some function f with, what's f? Because the value here is huge. Oh, it's just like, this is a knob. It doesn't do anything. So it just puts the value here and that's it. And on message, what it does, it actually, oh, it only supports read. So, you know, we had write, now we have read. And again, it communicates with something that I'm going to call the CPU. And it gets, basically reads this table and posts on this offset and posts it back to the CPU. So this is, in my opinion, this is the ROM. And if this is, you know, the read-only memory, we have only read supported here. There's no write functionality. This is the read-only memory. And if this is the read-only memory, this is probably the program. This is probably the bytecode which we have to analyze. But someone was, well, me in this case, was nice enough to actually have separate functions for all of the opcodes, which means analyzing this will probably be easier than normally. Oh, KrzaQ says that it ensures, this part ensures that a constant might be an integer, which is correct. That's correct. Looking at all these constants, actually all of them are integers anyway, but maybe the idea was different at the beginning. We already looked at this one, right? We looked at this one. This one was the RAM one. We looked at this one with the crypto, this one with like an pipe device-ish. Did we look at this one? No, we didn't. What's going on here? It gets to arguments. Then what does this void mean in JavaScript? Does it mean that to ignore this or something? I don't know. If a is equal to 102, so this argument needs to be 102, then post message system IRQ 7 and post it to 0. And I guess we already saw this, and this was basically, oh, and post t here. And this was, I guess, the, we can backpedal into it. Yeah, it's here. Right, so it's just like posting back the response. So whatever device we just looked at is basically the output or the communication with the outside world. So this is a pretty important device. Now we have a couple of more to analyze, I guess. This one, what are you? Oh, you are actually calling some functions. And there are some constants here, and there is this function. So okay, on message, what's happening here? We have two arguments, t and a. If t is in n, which is this array, then we post message to, it's basically like a mapping. It maps this number to this number and posts a message there. Doesn't look too interesting, to be honest. Just like a relays the message. Now, but this is called, so it actually sends a message to 16, whatever 16 is. I have absolutely no idea if this is 16, maybe this is 16, I don't know. It writes to like these three values, 0, 1, 2. Actually we did look at something like, you know, like this. Oh, here. Yeah, this looks familiar. It seems to be initializing this array. That's good to know. And I guess we have another one. Like this is, oh, we already looked at this one. This one was the message router. We didn't look at this one. I'm pretty confident. KrzaQ 1 says void is for evaluating an expression and giving undefined instead of its value. Makes some sense. So what's going on here? Let's see. Well, there are a lot of functions. What kind of functions? I don't care. What we care about is on message. So on the message, but there are like it also sets a timeout for something. So this is like 1E3 is a nice way to write just 1000. So, and this is the timeout says 1 second, right? And 1 second run O. So this is actually like another function which we need to take a look at. Let's just focus here. For anything, it just calls basically Y. So we need to take a look at the Y function as well. Let's maybe start with the O function. What does the O function do? Where is the O? I'm sorry, am I blind? I am probably. Oh no, here it is. It sets T to T. What's T? No, seriously, what's T? Oh, T is 0. Okay, so it sets T. Oh, there's, you know, some array here as well, which is 16 bytes. Good to know. So it sets T to T, and then it increases T. Then it sets Y to W, Y, what? And then it calls N with T. So now we go, oh, N is actually just here. It posts a message to 222 with error. So this is probably reading. It might be either directly RAM, ROM, or the, we did see some like relaying of messages to something that looked like RAM addresses, so maybe to the memory controller, let's call it like that. And yeah, and then it actually, then the on message is, this one is called, and it calls Y, and Y, what's Y? Y is null. Why is Y null? Oh, because we said Y to W here in the O when we were analyzing it. Well, it said. So let's look at W. Where are you, W? Oh, here's W. So what it does, it sets C to 255 and O. Okay, so I guess O might be a bigger value, and it just gets, you know, the first byte of it because it's FF, like OXFF. And if C is in A, this is A, then it actually calls it with O as an argument. So I guess O is the opcode, A is, this is actually the instruction set of I'm writing with a mouse, it's terrible, I'm sorry. Yeah, this is like the opcodes. So knowing this, I guess we can, oh, and these are the constants which we saw in the ROM module. So knowing this, we can already say this is the CPU, and all these are implementations one way or another of some instruction. And I guess that's pretty clear here anyway, because there's like a, why else would you have 3 different functions, one doing XOR, one doing add, and another doing subtraction? You wouldn't, right? So that's that. Okay, and it calls O again, and O again does this, which is, I guess, gets opcode from ROM, and then yeah, and then the W function is called again, which finds the opcode and executes it. So I guess we pretty much know what's going on, right, about it. We are dealing with a VM. The VM has several modules like ROM, RAM, everything working in a different thread. Then we had like the input device, the output device used to communicate with the outside world. So let's try to do, can we do a breakpoint somewhere on this and see how it works? Let's do a breakpoint on W, where's W? Here's W. Can we break on this? So I guess we have to enter 24 letters. No, access denied. We cannot breakpoint on this. I guess we have to breakpoint on the non-minimized version, which is a pain. So I guess I'm not going to actually do a lot of breakpoints. Okay, so what we have to do is we have to basically go to the ROM module. Where is the ROM module? Are we the ROM? Yeah, this one. And yeah, basically just execute it and see what values we have in what what's it called? In what column? Not column, in what row? And then once we have that ready, we can basically yeah, start write a disassembler. So this is what I'm going to do. I guess, can I change it quickly to Python, or do I need to change it to Python? Yeah, I'll just change it quickly to Python, so I'm going to do function to def. Okay, then like we get rid of braces entirely. We get rid of closing braces entirely. What do you mean you have not found? Perfect. Okay, and now like, yeah, it's just add this. Yeah, I know there's the debugger directive, but it means that the code I was modifying wasn't actually the code which was going to be executed, which is a little annoying. I guess this was another function, so I will have to change this a little. I guess I cannot use. Oh, this is going to be a pain. Yeah, no. I'm going to backtrack it. I'm just going to use JavaScript after all. So let's do it in a different way. I'm going to copy paste it into. This is not my console. Where is my console? Yeah, console. No. I guess it doesn't like this. Let's do it again. Okay, perfect. Now, A is equal to this thing, which is okay. How much of a... Oh, there are some values here. I was going to say like, yeah, we probably just need to dump the first ones, but I guess that's not the case. How am I going to export it to... Can you just like show me? It's just like 4,000 values. No, I guess you cannot. For that I equals 0, I 6 I plus console log. Oh, this is going to be k equals this, k plus equals now the value. So what was the array called again? Was it called O or was it called A? Okay, it's called A from I plus actually a colon, and that's it. Yeah, do it. Perfect. And this is exactly what I need to copy. So let's just copy this. I'm going to create an array in Python based on this. Txt. So yeah, basically reverse engineering a virtual machine 101. Copy. Maybe not txt. Let's just call it like rom.py. Rom equals a list. Yeah. Okay. And now I'm going to do like a disassembler of this.py, and I'm going to import from rom, import rom, basically. Now, okay, and now I need to actually do the reverse engineering of what is what and why. So by now I know that if we go, so where's the CPU? Perfect. That the opcode is only in the lowest bit, right? So, and I guess also looking at the ROM, there is no opcode 0. So opcode 0 might have a, unless this is, no, it wasn't. It was just a rotoring. So I guess opcode 0 means like end of stuff. So when I will do the disassembling, I'll just do this offset. Yeah. But I do the disassembling, I'm going to stop if the opcode is ever equals to 0. So print the opcode. So hex equals O and F. Okay, perfect. So for I in range while IP equals to 0, while because that was what the T was, the capital T was set in the CPU, right, at the beginning. while IP is equal to no, while ROM of IP and is equal to 0, then not equal, obviously. This O IP equals plus equals 1. Okay, so let's run this and see what happens. This ROM is not defined, obviously, because it's capital case. I is not defined because it's IP. O is not defined because it's ROM IP. Yes. Okay, so it does something, and I guess I can, well, it starts with FF, that's pretty funny, but I guess I can go through the CPU now and through this code and analyze it to see what's what. So let's start with FF, which is, you know, basically like 255, right? And it calls the B function, so let's look for the B function. And the B function is... where's the B function? Oh, seriously. B. Yeah. Okay, here's it. It sets the timeout. Oh, it calls... oh, so it's a halt instruction, like or pause. Basically, it does nothing. It's a no-op, but it does it for 1 second, I guess not 2. When it's waiting for the password, maybe it's just in an idle loop. So yeah, so like do nothing. I'm going to call it and our FF is how are we going to call it, like HLT, just because this is the Intel opcode, right? So return this and if op in inst, then print inst op, else print the hexadecimal value. Perfect. So we already know that, yeah, our disassembler already shows this. Our disassembler actually sucks because it doesn't show the IP, which is bad. It always needs to show the IP. So I guess I'm going to do something else. I'm going to do like s equals for x, and yeah, and this is the IP. P now. Yeah, standard disassembler. If you've done it once, you basically know everything you need to know about it. If you haven't done it, then this is your chance to learn, I guess. Yeah, so yeah, the IP and the instruction, and now we need to decode the instruction 1. What's the instruction 1? 1 is U, so let's look for U. It's this thing. It's okay. This is a funny one. T equals C from N, so this is C. It basically does byte splitting. Yeah, it takes a D word, which is, you know, for bytes, right? And it like takes the first byte. No, it takes the second byte and puts it in the first argument. Then it takes the third byte, puts it in the second argument, and so on. So it basically returns an array, right? And then this says W. So it's W. 15. What's 15? It's O X F. And T. So the argument, the first argument. This is registry assignment. V must be like an array for registers. Obviously, it has like 16 8-bit registers. So yeah. So this is like load an immediate value into the register. Perfect. I guess I'm going to do like similar functions. I am going to even copy this JavaScript function and do the same thing. So this, no, just def, obviously. Is this code valid in... I'm pretty sure it is valid in Python, but I am not super sure about these parts. I'm just going to do this. Let's call it arg3 and let's call this arg2. Arg2, wow, this argument is pretty huge. It's like 16-bit. Okay. And okay. Okay. So now I know that arguments were arguments, and this has no arguments. Then one actually, I'm going to call it move, and it has 2 arguments. And the first one is a register. How am I going to denote it? Let's maybe just call mark, because it calls what? It calls C, right? It doesn't call S. Yeah, it calls C. So let's do this. Let's do none here. And let's do, I don't know, prefixes maybe. Or like some... So what are the arguments? This is the first argument, then the immediate value, right? So I, and then there's actually no further arguments, so I'm going to ignore it. And now I need to write some additional code to actually handle this, what I've written here. So, okay. No. If it's there, then mnemonic is the first thing. Oh, I probably should like align it to, yeah. Then the code function, so I'm just going to code it f, and then arg types, so arg t, and this is what I want. Perfect. Now I'm going to call the function to get the args, so args equals f from opcode, no, actually O, because that's the full opcode, not just the last byte of it. Okay, cool. And now I have the arguments, and now I need to go through the arguments. So I'm going to first write the mnemonic to it, plus a space. And now I need to go through for a in arg type. No, actually I and enumerate. I need to add to s depending on what's the type. So if a equals to register, then I'm going to add, let's say something like this. And this is the args from I. Else, no, if a equals to immediate value, there might be different types obviously. Then just add, like, I don't know, a hexadecimal value, maybe OX something. Yeah, args from I. Yeah, perfect. Looks good actually. Let's see what happens. It failed because obvious reasons. Okay. Here. If no, not here actually. Here. Yeah, we only parse arguments if there are any arguments, obviously. So yeah. Let's do this. Perfect. Oh, there are quite a lot of moves here, which is perfect. And I forgot a comma. Do we care? Yeah. I don't want to add the comma if it's, you know, the last element. Then, otherwise I want to add a comma. Perfect. Okay, so we move 1 to register 15, and then there is the fourth opcode. So we do the same stuff. It's err. Okay, and it actually binds a function. So y is the function is called, no, it binds to g. So the function is called g, and it posts something to 60, like O, and O is this. So okay, so 60 might be, it's probably not RAM, because that wouldn't make sense at this point, right? Because we put some value in the register and we sleep, but my guess is this is the device, the input device. We could verify it, but I'm going to assume this is the input device, and then it calls the g function, which basically writes to W this, and this was bound the S, right? And the S was, and W, so basically it writes to the register, the given register specified in the first argument, no, the first argument. It writes the value C, which is the value which it got from there, I guess, right? So, yeah, this is like in, basically, X4, it's in, same as x86 assembly, is like receive some data from a device. Is it calling C again? Yeah, it's calling, no, this isn't the right function, this is the right function. It's calling C again. And I'm pretty sure it's the register this time. Is it a register? O is equal to, no, this is probably the port, so this is not a register. No, it is a register, but it's reading from that register. And S, it's another register. So there are like two registers here. Yeah. One is like the number of port, let's call it, and the other is actually the destination register. So what do we have here? It reads and then it does like 07. Perfect. What's 07? Are there any questions? Yeah, there are. What is this drawing program on the screen? It's Zoom It. Zoom It from sysinternals from Microsoft, basically. How many points for this task? 350-ish, if I remember correctly. Is IDA capable of helping out reverse or generic bytecode like this? Yes, if you write a disassembler module for IDA, which is actually more work than writing it in Python like this. So I wouldn't recommend using IDA in this case. It's a good question, by the way. Okay, sorry, I'm now reverse engineering the 7th one, which is M. Which is here. Oh, there's a capital M and non-capital M. And what does it do? If 0 is equal to this, and then T was IP, like is the IP, it was set to 0 at the beginning and then this increment was the IP. Then it jumps to this, and it actually calls S, so it calls the, not C, right? So it calls the second function. Okay, so it's, yeah, if the register is equal to 0, then jump to somewhere. Yeah, okay, so I need to use the second one. So that was the 7th, right? So it's jump F0, so JZ, I guess. And that was, yeah, an immediate value actually. Okay, so I guess we can already analyze this for instructions. So like sleep, and then after you wake up, put 1 into this register, and then actually contact the device and read the 1 byte from the device into R0. And if R0 is equal to 0, then jump 0, which is jump to the beginning, which means it waits for input from the input device. This is like, we already know something. Then it does some setting of stuff, and it goes to OX2. So we need to now see in the virtual machine implementation what's OX2. And it's F. And this one. What's going on here? Okay, so it decodes the arguments, then... what? Oh, the first argument, sorry. And then it... What does it do? It basically like binds to S... Oh, E, okay. So it puts into a register, because, you know, it calls something. Yeah, NI. Oh, N, we saw N. N was already in O, I think, and the O function is reading, like, read from RAM. So it reads from RAM. Perfect. Now, from what address does it actually read from the RAM? It reads probably from from this address, which is made of 2. Why is it calling C in this case? It's reading basically. No, because we saw registers. I was thinking it was reading from the... Yeah. So yeah, you give it 2 registers, and it treats one register as the top value and the other, like top part of the address, and the other as the bottom part of the address. So yeah, so yeah, basically you have 3 registers here as... So what was this? It was 2, right? So let's call it LD, like load, and arc3, and you have 3 registers, which is the destination register and the low part and the high part of the address. Okay, and we have another part disassembled. Then we have 10. 10 is capital M this time. Capital M is here. It's just subtraction, like subtract from one register to another register. It's simple. So A, it's sub, and arc3, and 2 registers. Okay, so we can run it again. Now we are missing 6 and 9, so let's do this quickly. So 6 is D, and D, where are you hiding? D, perfect, it's XOR. So it's like this, but it's an XOR. So that's 6 and it's an XOR. And also 9. 9 is P, and P is... Sorry, where's P? Oh, here it is. It's addition. So these two are pretty simple. That's 9. Addition. Perfect. Now, are we missing any? Oh, 3. We are missing still 3. But we're getting there. We almost have everything disassembled already. 3 is called A, so let's look for the A function. A function calls the T with 2 arguments. This one looks a lot like what we had here, right? So making an address from the lower and higher stuff. And I, which is also a register value. And it calls T. What's T? Oh, T is writing. So this is writing to memory, probably. Yeah, that's my guess. I mean, it's the same destination, so it's writing to memory. And that was 3, right? Yeah, correct, 3. So star, like similar as in usual assemblies, and it's actually again RRR as the arguments. Perfect. Now we can disassemble a little more, and we are still missing 8. What's 8? 8 is H. And H is... That's the decrement instruction. You know, just decrementing the value in the register. So usually, like, decoding a VM isn't too hard. It just takes time. Okay. Perfect. Now we can read through this code. So, what does this code do? It initializes some registers, and then it loads from this memory address, which is... this was the top register, right? So it loads from the address 600 hexadecimal into the register 10, then it subtracts this value, XORs it, moves R1 to 0, then it does... This is a multiplication. Like, this is how you write a multiplication using only adds. Okay, KrzaQ says there's a question. Let's take a look. How do you write these types of tasks? What's the thinking behind it? Try it, basically. Try to create a challenge and you'll see everything, but it's there. The main part is to... You know, you have to always try to balance, so it's not too hard. It's not a lot of guessing, because guessing is discouraging. It's better to, like, there's something like an obstacle which is known, and maybe the solver needs to learn something first to solve it, but it has to be known, basically. So, and for CrackMe's especially, there must be only one valid solution unless it's planned for there to be more solutions. Anyway, so that's a good question. Wasn't that supposed to be decrement? And I've obviously written an increment. Thank you very much, KrzaQ, for this. Also, Arthur, also had a new TV, also session pool. Thank you. And also everyone else who noticed my mistake. Yeah. Okay, so yeah, and then there's some storing stuff somewhere. Now, the interesting part here is that, as you remember, one of the devices was actually memory mapped IO. So it might be writing to RAM, or it might be communicating with the device. And it does it until like it does some check here, R13. It moves 0 to R13 and it jumps to 9. What's 9? 9 is just load. Okay. Or it jumps to 100. So I guess we need to also disassemble whatever is on 100. So just going to copy paste it, print here. Yeah, let's see if there are any. Oh, there is 5. We still don't have 5. L. And L is this, which is, it posts a message to 60. We know 60. 60 was here as well. And it gets values from 2 registers. So what was this R about? Oh, it was reading a value from the device. So this is probably writing a value to the device. That's my guess, and it would even make sense, right? Because this is 4, 5 is all out. Okay, so this writes to device R4, so 18. It writes 13, so it writes 0 to that device. Okay, but it might also jump to this address, so we also need to disassemble that address. So I probably should make 0, 100, 120. Okay. Yeah, so I'm not copy pasting this code around. Okay, and it does out to R4 and jumps to 0, but this is different, right? Yeah. So I guess this is like, remember there was this device, right, which took 1 byte and let me try to find it quickly. Yeah, this one. It's exactly this one, which takes 1 byte. This is the byte T, and posts this value to with a system IRQ, and the system IRQ 7 actually was what was the response whether the password is correct or if the password is not correct. Now, which means that this is basically we jump here if the password we enter is correct. So this is something we already know. Now, I guess we need to have this condition met, and to have this condition met, so R5 must be 0, and so R5 will be 0 only if R5 matches R4, so it matches 18. Now, 18 is actually, it's 24 decimal, so this is the length of the password. So I guess it means like if after validating the whole password, if the length is equal to of correct characters is equal to 24, then that's it. You're done. Perfect. So how do we go about it? I guess it's at this point it's already super easy to brute force, probably, because just because this is, we know it compares the length, we already know that we can change probably this length to or just monitor the register value at this moment and know what's the length of the correct password. So I guess I'm going to go for that solution, just to brute force it, not to reverse engineer the rest of it. Or I could just reverse engineer the rest of it and figure out how to get the password from the constants we saw all around. I'll prefer the brute forcing approach usually, because I don't have to think, and I like not to think. I am a lazy person. But to do that, I'm going to need to actually be able to execute this CrzaQ, and to be able to execute this CrzaQ, I need to dump a couple of things. So let's maybe start. Do I have downloaded? I need to download it again. Okay. Now I'm going to remove this part. Yeah, and I'm going to change it to like CrzaQ.js. Okay, perfect. Now this where's the... Oh, I called it ASDF, obviously. So I'm going to copy and call it... No, I'm going to change it here to ASDF, because if I have two files containing the same thing, I'm probably going to use my editor on a wrong thing. Yeah, so I put in the Starbase, I put ASDF here. Okay, now I'm going to run it just to see if it works. Yeah, it works. So it works locally and perfect. Now I'm going to start playing with the workers, as in... no, not here. I obviously meant ASDF. ASDF is already opened, you say, so here it is. Perfect. Now I'm going to find the workers, and I'm going to... Oh, here they are. Which worker is which? Which worker do I need? That's the correct question here. I guess I would probably need the CPU worker. That would be really useful to have. Yeah, let's do some hooking in the CPU worker. Now, what's the number of the CPU worker? It was 167 decimal. I'm not good enough to actually know what's 167 in hexadecimal. It's A7. I am actually good enough. Yeah, it's A7. So this one, it's this worker. So I'm going to grab it. I'm going to change it to CPU.js. CPU.js. I'm going to decode it, obviously. So this is B64, and I'm going to again run my Python magic on it. Yeah. It's actually great in Windows that you can just like, if you run Python again, it has like the console has per executable history of commands. So that means if I run Python again, I can just use the previous commands. So that was CPU.js, B64, blah blah blah, perfect, and now I can do this. I'm actually going to write binary, in all honesty. Yeah. So excuse me, can I have what was stupid what I did? I should have just grabbed this version. No, this is the ROM. Where's my CPU? This is the CPU. I should have just grabbed this and pasted here instead of playing with Python at all. So yeah, let's keep it here, and now I need to check if my code still works. So where is the... Do I have two browsers open? No, I don't. Okay, let's just run Starbase. And I broke something. What did I break? Failed to construct worker script cannot... Oh, okay. So it doesn't like that I'm, running, in the file origin. I try to construct a worker based on this origin. So I have to create a www server, which is like python-m simple HTTP server done. And now I can actually like HTTP 127.800 and starbase.html. Yeah. Now it works. Perfect. So, given that I already have this, I can now do some instrumentation. I already told you what I'm going to instrument, right? What I am going to instrument is... I'm going to do actually a couple of things. So, this is the ROM, this is the CPU. Where's my disassembler? this part. This part checks whether what's the length. So at address 100 hexadecimal, I'm going to check R5 register value. Yeah. Therefore, O was the function which fetches the instruction. Where is that function? I'm basically on it. Okay. So if t equals 100, I would like you to console log the value of register 5 for me, please. And let's see if it works. I need to obviously like control F5 it a couple of times maybe, just to be sure. And now I need to have my console here. Oh, fav icon, that's okay. Sweet. Let me maybe make this window a little smaller. Maybe let's move this console here. Now I'm going to put something, and it's 0. Okay, so it works. Basically, my script works. I already know that 0 characters are collect. Now, on our CTF, we knew that every flag started with D, R, G, and S, and then there was a curly brace, so let's do this. And yeah, and 6 characters are correct. So now what I'm going to do, I'm going to check basically all and every character until this value is equal to 24, and when it's equal to 24, I get the flag, right? This is the lazy man solution. Now I'm not going to manually check this value. I'm going to... what am I going to do? I'm going to write a loop that does it for me. And the loop will be in the SDF. And it's going to be run when... oh, probably here. No. This makes sense. Where do I want to have this loop? Maybe I should actually have like a set. What's the best place to place it? Maybe, well, here is not too bad actually. Yeah, let's do it here. Okay, so I'm going to do a global variable. The global variable is going to be called brute. And brute is going to be equal to, no, it's going to be equal to the character code of space, which is 020, obviously hexadecimal. So, known, so const p password. Okay, it's going to be D, R, G, and S, and then a brace plus the ASCII code for brute. How the hell in JavaScript do you do this conversion? I honestly don't know. JavaScript Unicode to character. Perfect. To character. Yeah. Maybe just like code. String from code Starbase is perfect. And brute. Okay. And okay, so this is going to be called, and then it's going to call the callback with the response, right? But I needed to... I'm going to actually console log pass. Yeah. I'm going to log it, and then I'm going to call it, and the CB which is going to call to be called is actually my function. Now, and I'm going to actually bind this function to... yeah, I'm going to bind it. So, function like response, I'm going to... can I do it like I want to do it? I think I can do something like this, right, in JavaScript. I'm going to bind it to this object, just because. Okay, so now I'm going to console log. I don't even have to log it, I just have to like if brute is less than 7e, then I'm going to actually increment it. So broad ++, and I'm going to call this login like this, .login. Again, p is ignored, so whatever is df. Callback is ignored, so whatever, like xxx, yeah, okay. Sweet, this should be enough. Let's see what happens. So again, I'm going to reload it a couple of times. And I'm going to enter all the... Okay, yeah, and it starts to brute force all the characters one by one. Now, it's slow. I know why it's slow. It's slow because in the CPU there's this sleep instruction, right? There's this, like, set timeout. I'm going to change it to 25. Probably my CPU is not going to be too happy about it, but whatever. Yeah, now the brute force is way faster. But it says 0 all the time. Why does it say 0? It should have says like 6 or 7, right? I am doing something incorrect. Oh, I know, because the total length of it is not 24. I guess it expects really, like, checks whether the length is 24. So, yeah. So it's 6, 7, 8, 9, 10. Yeah, now it should be. So it's like 17 plus 6, so 23, 24. Okay, that should be fine. I know that it's a curly bracket on the end. Okay, let's just restart it. Yeah. It's again 0. Why is it 0? Because I'm still not passing pass. I'm sorry, my mistake. Yeah, so I'm basically looking for 7, like at what character will it be 7? Oh, it's 7, it's here. A was the correct character. So I guess I know that. Maybe I should do this like a global variable out of it. So, sorry, it was capital A actually gave me a 7. So I know that this character is A, and I can decrease this. Or R equals, actually no, can't even, because I don't have the value which is displayed there, so that won't help me. Yeah, let's just do it like this. Though I do this like the format in which it's printed. I don't think I can do anything about it though. Yeah, so we can now brute force the second character. Still not there. Okay, here it's B. So that's A, B, and so on, and so on. And we could actually go forever like this, you know, character by character, and in like 15 minutes we would have a whole flag. Now I actually do remember the flag, so I'm not going to go there. We're going to just brute force the last character. So it's, I'm going to do this last character, so it's Abriel, ABFO. I don't remember, but I remember Intex. This one. F01 DCC 61. Well, 1 is the last character, but I'm going to just show it again that I can brute force the last character. Yeah. Yeah, and that's it. Here. And this is the correct flag and correct solution for it. I actually thought this will take me a little shorter to reverse engineer on stream, but it seems that's not the case. So I'm going just to, I'm not going to go through any more tasks probably. I am going to show you one more task just so you can play with it if you like. I guess in the end, if you go to our blog, right? So I guess let's check if it even works. So Starbase. 5 ABF01 DCC 61 and curly bracket access granted. Perfect. challenge solved. So yeah, so that was my CrzaQ for this CTF. Now another challenge is if you go to my blog, but you change that base into starbite.zip and you download it, then what you get is a zip file, obviously. And the zip file, you actually have to enter the flag, which I just because this is the third level, so you have to enter the flag from the previous level. And this is another challenge which I prepared. Okay. Now, if you look at it, it's actually a WAV file, right? We can close this already. Yeah. And if we open a WAV file in... probably not the best idea. Yeah, I usually store my passwords as directories on my drive, so we cannot see it. I am sorry, apologies. Okay, if we open it in Audacity, then well, you have to zoom it, but it looks like this. Now I'm going to basically tell you how to start, and if you like, finish this challenge. Every 10, like this is easy, right? This is 0 and this is 1. This is quite easy to see. And basically, if you grab 10 of them, so that would be up to here. Actually, no, that's incorrect. Again, starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is one ASCII character with 2 zeros at the beginning. This is 10 bits. And this is like an ASCII code of a character. Make a Python script, go through all the values, decode them, basically like, you know, get zeros, get ones here, 0, 0, 1, 1, and 0, then decode it into ASCII, and then get a text file, and then work from there. So this is basically your homework, if you like. And again, it's this task is available on the following URL. I'm going to note it somewhere. HTTP, again, val code.pl, starbite.zip. Yeah, like this. I'm going to paste it here and there. Yeah, and good luck with it. Again, the flag, well, you saw the flag, so just rewind this video to read the flag so you can extract it. I think if you actually go to, I think there was a version which I uploaded which didn't contain this password, though I do not remember it. Maybe it's .wave. Check it. And that's about it for today, actually. So I'm going to answer a couple of questions if there are any, obviously, and then I'm going to leave you with the mission. The fourth mission will be displayed at the end of the stream. So that's that. Okay, and let's see if there are any questions. Oh, I have seen some from Dimitris. I have seen a similar assembly on Intel 8085. The instruction that loaded the RAM using 2 register was called LXI and used 2 8-bit registers to form a 16-bit address. Yes, that's true. The instruction wasn't my invention. I also saw it, yeah, on was it the same? Yeah, I think even on the same CPU. I think on my university I played with it. Yeah, that's it. So I see there are not any more questions. I guess that does make sense. So thank you very much to KrzaQ for being today's moderator. And I'm not sure about the next topic. So if you have any ideas, just leave them in the comment section under this video. There's another question. How did you get into CTFs and hacking stuff, etc.? Basically, some person on an IRC channel I was sitting on dumped some, like a link to basically a hack me challenge, like a war game, a JavaScript war game, like with several levels. So I done it. It was like really fun for me. For context, I basically always thought I would be a game designer, like a game programmer, right? And for I guess until I finished high school and went to university, I thought I would be a game programmer. So it was a game developing channel, but yeah, and then another person came with another war game and another, and I said like, hey, this is fun. And then for some reason I actually got into reverse engineering because I wanted to like take a look on some network protocol, but if I did it with a proxy, it was too slow for my taste. So I wanted to like hook into the applications. So I started learning reverse engineering, and then by some random reason, I got also in stuff like, buffer overflows and so on. And I started working in an AV company instead of a game company. And yeah, and then like more, basically like security is for me equally interesting as game development. I really love both of them. So kind of by accident, in all honesty, I get into security. Yeah, and for CTFs, basically, we're in my, in Poland, there was, the security scene was always pretty active, and there were, even like 2005-ish, 2004-ish, there were CTFs. They were usually individuals who played yourself, not with a team, and they had offline finals and so on. So, yeah, I basically like started with CTFs around 2004-ish. I guess my first finals was in 2005, and in 2006, I believe, and 2007, I won the finals for like it was called Security Days CTF, which was pretty fun actually. So yeah, that's how I basically got into CTFs. And then, Dragon Sector was created years later in 2013, so yeah, or late 2012, depending on how you count. What's the weirdest, most clever CTF idea you've seen out there? Two of them. First of them was called... What was it called? I don't remember what was it called. Murmur, probably. It was a pickup of Mumble. Mumble is an open source voice chat, like TeamSpeak, but open source. And the task was a pickup of conversation on Mumble, and it actually uses proper crypto, and it uses it properly. There is no bug there. There was no bug where everyone was looking for a bug in the crypto. There is no bug there, at least as far as we are concerned. So yeah, so you have a pickup with encrypted voice communication. How the hell do you decode it, right? So I basically decided I'm going for a walk, and I started thinking, how do you create a task which has proper crypto and it's still solvable? And the answer, it's basically came to me due to a paper I read. Is because when there is silence, there is no packets. And if there is no silence, there are packets. And the packets are, depending on how long the word is actually might be variable length, right? So I came back to the computer, I launched Wireshark, and asked it to print me a timeline of the packets. And you know what? It was Morse code. So I looked at the timeline and just okay, this is dash dot blah blah blah, and I get a flag. And I think only 2 teams solved it on that CTF, and people were so annoyed by that task, and I really loved it, and it was pretty weird. So that's one. The other one was on Plate Parliament of Pwning CTFs a year ago. They gave you a trained neural network, a TensorFlow neural network, and told you, well, find what it's trained for, and you basically had to send it an image, and it told you yes or no. So yeah, I did some genetic algorithm approach to it to get a really weird looking set of combined images which the neural network said yes to. Now it was trained on rambutans. Basically, a rambutan is like a small red fruit of some kind. It looks really fun. I can actually show it to you. Let's switch to desktop and let's launch the browser. There was also another challenge which I didn't participate in that CTF, but I've heard about it. So rambutans. I'm sorry if I totally mispronounce it. Yeah, this is a rambutan, basically. I'm sorry, the quality here isn't great. Yeah, maybe this one. Yeah, this is like a rambutan. If you don't know what that is, I also don't know what that is. Now, if there was one more task, it was something like UCG, CUC, something like that. Like a whole category name spun out of it. We called it utsuktuga. And it's because you get the text file and there were only like letters UCG and so on, and you had to guess what is it. And it turned out it was this rotating thing. It was DNA of an apple, and you had basically to write apple as a flag, and like nobody knew what is it. So that was hilarious. Probably the weirdest I've heard about. Or an obfuscation technique or a system quirk. For obfuscation technique, the Page Fault Liberation Army. That's epic. Just look it up. Page Fault Liberation Army by basically Sergey's people, Sergey Bratus from the University of Dartmouth College. Like he's like his students they have really awesome research usually, and like Page Fault Liberation Army was awesome. So take a look at it. Can we have the zip pass in the chat so I don't have to rewind it? Yeah. .wave has no pass, I think. But I am going to give you the password on the chat. Yeah. Here you go. Okay, and that's it. So thank you very much for being here today. KrzaQ, thank you very much for being my moderator again. And yeah, so if you actually speak Polish, there will be no stream tomorrow, but there will be one Friday. So it's actually moved from Thursday to Friday this week. Sorry about that. Yeah, and see you next week for the English stream as well. If you have any comments or so on, just leave them under the video. Thank you, and have a great evening, great day, whatever time zone you're in. See you, bye bye, and have fun with the mission.